Hey everyone, welcome back. You know how much we love diving deep into all things space, right?
Absolutely. Can't get enough of it.
Well, today we're taking a look at something truly spectacular, something so vast and powerful that makes everything else seem kind of tiny. We're talking about the life cycle of stars.
Oh, yeah. It's mind-blowing when you really start to think about it. Stars, they're not just pretty twinkling things up there.
Exactly. They're the ultimate cosmic engines, shaping galaxies, forging elements, and yeah, they even created the stuff that makes up you and me.
We are stardust, after all.
So where do we even begin with a topic as massive as this? I mean, a star's lifespan's billions of years, right?
Yeah, it does, but even these giant, fiery balls of plasma have a beginning, a middle, and an end, just like us.
Right, so how about we start at the very beginning? Where do stars come from?
Every star, every single one, begins its life inside a nebula. You know, those massive clouds of gas and dust you see in those amazing space
Oh
pictures?
yeah, like the Orion Nebula. That one's pretty famous, right?
Exactly. It's a stellar nursery, basically, filled with the raw ingredients for stars.
So it's basically just clouds of stuff hanging out, and then poof, star.
Well, not exactly poof. It takes a lot of time, millions of years, actually.
Oh, okay, so what happens?
Gravity is the key. It slowly pulls all that gas and dust together, squeezing it into these dense clumps.
So it's like everything's getting packed in tighter and tighter.
Yeah, and as it does, things start to heat up in the center of those clumps, like a lot.
So how hot are we talking?
We're talking a mind-boggling 10 million degrees Celsius. And when the core reaches that temperature, something incredible happens. Nuclear fusion ignites.
Wait, 10 million degrees?
Yeah.
I can't even imagine that kind of heat.
Yeah, it's insane, right?
So what happens when things get that hot? What is this fusion thing?
It's the heart of a star, literally. Hydrogen atoms start smashing together, fusing to form helium, and releasing an insane amount of energy in the process.
Okay, so that burst of energy, is that what makes a star, like, turn on, like flipping a switch?
It's more like a slow burn, but yeah, that's the moment a star is born.
Whoa.
From there, the star enters its main sequence, the longest phase of its life.
Main sequence.
Mm.
So, like, it's the star's prime time.
Exactly. For billions of years, it's going to hang out, steadily fusing hydrogen into helium, radiating light and heat.
That's where our sun is now, right? Like, in its prime.
Yep, our sun's a main sequence star. It's been shining for about 4.6 billion years, and it'll keep going for another 5 billion or so.
Wow, we're right in the sweet spot then.
Yeah.
But eventually the fuel runs out, right?
Yeah.
What happens to a star like our sun when it runs out of hydrogen?
Well, things start to change. The core contracts and heats up even more, but the outer layers expand outwards. It becomes what we call a red giant.
A red giant. So, like, the star gets bigger.
Way bigger. Imagine our sun swelling up hundreds of times its current size, engulfing Mercury, Venus, probably even Earth.
Hold on. That's not good. We're going to get swallowed by the sun.
Well, not for another 5 billion years, so no need to panic just yet. But yeah, it's a pretty dramatic transformation.
So after the sun becomes this giant red thing, what happens? Does it just, like, fizzle out?
Not quite. The outer layers of the red giant eventually drift away, creating what's called a planetary nebula.
A nebula. So, like, it goes back to being a cloud.
Kind of, but it's a spectacular cloud. It glows with all these beautiful colors like a cosmic fireworks display.
That's kind of beautiful, actually.
It really is. And what's left behind at the center is the core of the star, a white dwarf.
Okay, so white dwarfs, those are the crazy dense ones, right?
Yeah, they're about the size of Earth, but pack almost as much mass as the sun.
Wait, how is that even possible?
Imagine squeezing all the stuff in a jumbo jet into something the size of a grain of sand. That's how dense a white dwarf is. It's basically the leftover embers of the star slowly cooling over billions and billions of years.
Okay, that's just mind-blowing.
Right.
So that's what happens to stars like our sun. But what about the really big ones? They don't just turn into giant space embers, do they?
Nope. The death of a massive star is a much more explosive event. Instead of quietly fading away, they go out with a bang, a supernova.
Oh, wow, I've heard of those. They're like the biggest explosions in the universe, right?
Pretty much. Imagine a star suddenly blasting apart, shining brighter than an entire galaxy for a short time. It's a truly awesome spectacle.
Okay, so that's a lot of energy being released. What happens to all that stuff?
A supernova is a cosmic recycling plant, basically. All the heavy elements forged in the star's core, things like iron, gold, and even uranium, get blasted out into space.
So those elements, they just become part of new nebulae.
Exactly. They become the building blocks for new stars, new planets, and eventually even life.
So The stuff that makes up us, it literally came from exploding stars.
You got it. We are all made of stardust.
That's so wild. So what about the core of that exploded star? Does anything remain?
Depending on how massive the star was, the core can become one of two things: a neutron star or black hole.
Neutron stars. Those are the ones that are like super tiny but incredibly dense, right?
Yeah, a neutron star is only about the size of a city, but it can have twice the mass of our sun.
So even denser than a white dwarf.
Way denser. Imagine a teaspoonful of neutron star material weighing billions of tons.
Wow, I can't even comprehend that.
All right.
And what about black holes? Those are the like ultimate cosmic mystery, right?
Black holes are regions of space-time where gravity is so strong that nothing, not even light, can escape. They're formed when the core of a supermassive star collapses in on itself.
So if light can't escape, how do we even know they're there?
We can detect their presence by their effects on the surrounding matter. They warp space and time around them, and we can see that.
So even though we can't see them directly, we know they're out there, lurking in the darkness.
Precisely. And that's what makes them so fascinating, so mysterious.
Yeah, I can see why people spend their whole lives studying this stuff. It's incredible. So we've gone from tiny specks of dust to massive stars, fiery explosions, and mind-bending objects like black holes. It's hard to even grasp the scale of it all.
It really is. But I think that's part of what makes astronomy so captivating. It reminds us just how vast and mysterious the universe is, and how much there still is to discover.
And how connected we are to it all, right? I mean, we're literally made of stardust, forged in the hearts of stars that lived and died billions of years ago.
Exactly. We are a part of this grand cosmic cycle, a story that began billions of years ago and continues to unfold today.
And who knows what the future holds? Maybe one day we'll uncover even more secrets about these amazing celestial objects.
I have no doubt about it. The universe is full of surprises, and the more we learn, the more we realize how much we don't know.
Yeah, that's a humbling thought. Well, for all of you stargazers out there, I hope you enjoyed this deep dive into the life cycle of stars. Next time you look up at the night sky, take a moment to appreciate the incredible journey each of those twinkling points of light has taken, from birth to death, and maybe even rebirth. It's a story that's billions of years in the making, and we're all a part of it.
Absolutely. It's a reminder that we're all connected, not just to each other, but to the entire universe.
Thanks for listening, everyone, and as always, keep looking up.